The following presentations are selected by the program committee from the entries received in response to call for presentations. The first presentation is delivered by Mr. Hiromasa Ishii. He is in charge of infrastructure and network construction lecturer at CSK, and he joined ISP in the Philippines as a GM, and he participated in the development and startup of mruby at the embedded system division of Kyushu Kabushiki Gaisha CSK, and he has been working as a Deputy Secretary General of a Ruby Forum Lightweight, and he has been lecturing about mruby and mruby forum management, and lightweight mruby forum chairman is Mr. Yukihiro Matsumoto, and also the speaker is Hirohito Higashi. Long experience in web application development embedded system. In 2015, he became the senior researcher of Shimane Software Research Institute, and he is developing a lightweight Ruby language mruby/C and alone framework for embedded system. Today, they are going to discuss under the theme of enhancing learning. Thank you very much for the very kind introduction. I am Ishii. Today we are going to talk about going beyond the embedded issues. How companies are using mruby and mruby/C, and the new API reference guidelines for mruby and mruby/C, what kind of advantage and benefits there are. mruby, it said that it was born in Fukuoka. All around the world, people congratulated on the winning of the championship by Hanshin Tigers baseball team. And Avispa Fukuoka is a professional football team in Fukuoka. And on Saturday last week in Ruban Cup Championship, they won, beating Urawa Reds, and they became #1 in professional soccer championship. And Avispa Fukuoka has been going back and forth between J1 and J2 championship, and there was such a big event in front of a Fukuoka City office, and even to Hakata railway station. All the football players of Avispa went to with their fans and had a very big party outside. And B is the character for Avispa Fukuoka, and they stung the Urawa Reds, and we hope that we'll be able to more or less have such a stimulating experience from mruby and mruby/C. Even with the small resource, it works. It's been 10 years since mruby was released from Fukuoka Kyushu Meiti and Kyushu Institute of Technology, and with the leadership of Mr. Matsumoto, mruby was invented. It worked on 400 kilo K. Today, it is able to work under 100 kilo. And 4 years down the road in Shimane, mruby/C, a new language was developed on a 1-tip micro controller. 16-bit is the target, and it works with a 40 kilobit, and it is able to do a multitask with the independent scheduler. And the Pico Ruby is also born in Shimane. Now mruby or lightweight Ruby, how are they being used? It's not easy to see how they have been used, but in the past 10 years, pull requests for mruby exceeded 6,000. So in just about 10 years, that means 600 per year, and about 2 pull requests from many people per day, and Mr. Matsumoto and volunteers have been helping on them, and in 1 or 2 days they address those requests. And Mr. Matsumoto in the past 2 years have been having such requests on his GitHub every day, and not soon he is going to be on Guinness for the number of the requests he receives on GitHub. But how has it been used in companies actually? Ruby Contents Business Promotion Association and iTalk, Shimane Software Research and Development Center have helped us in doing some studies and a questionnaire survey on companies about how they have been using mruby. Green indicates that they have been able to use Ruby well, and the black indicates they gave up on the use of lightweight Ruby. And hardware on the top and software companies down at the bottom, and what language they are using usually. In the left, C language; on the right, mruby or mruby/C or Ruby. And they were so nice to respond to a questionnaire survey all of a sudden. Now, company A. The president is a Rubyist. He loves Ruby and he enjoys writing a program in Ruby. This is the software vendor, and this company, in order to realize IoT, was able to found a sensor, and he wanted to make an IoT product, and he wanted to use mruby. But this company has no knowledge of hardware. So as a result, for the printed circuit board, they outsourced hardware to outside. And hardware vendor agreed to the use of mruby. mruby and mruby/C. Hardware vendor was also interested in those languages, but when they began to use, they found the various shortcomings of mruby. As a result, they decided to switch over to C language for development. So just to have a successful development and to make a program usable on microcontroller through porting of mruby or mruby/C requires a lot of skills and knowledge. If it is a very first experience and trial for the companies concerned. What about the company B, equipment machine manufacturer? They have been using C or PLC for development. They know hardware, but they have little knowledge of software. But the person in charge was very willing to acquire new technologies, and by using mruby, also AI, they wanted to embark upon the development, but they didn't have enough knowledge of hardware. So they asked to outsource hardware development. But that company was a specialist on C, and they didn't know the difference between Ruby and mruby. They worked really hard, but they were not good at Ruby or AI, so they gave up on the use of mruby for their program. But there is a successful example. This is a software vendor. The leader was an experienced developer of a C language, and the young engineers who learned mruby/C for the first time worked as a team, and they were successful. They used a board which works on LoRa LPWA, which is applied with the existing microcontroller board. They put mruby and C, and of course they had a support from outside specialists. As a result, the young engineers were able to accomplish mruby/C, and they were able to rewrite application software on a remote basis, and they were able to make a product in just about 2 or 3 months. And another company, company D. D outsourced hardware and software. They knew C and mruby too. So they were able to develop a program from mruby. So as these examples show, first, the knowledge of hardware is necessary, and also the cost of learning a new language is important. And also the important point is that you shouldn't try to do everything with lightweight Ruby. And on the other hand, as other speakers mentioned, the language processing is very good at Ruby. So what is difficult with existing embedded language like C? It's what lightweight Ruby is good at. And perhaps you can start small with the use of Ruby. For instance, QPS Research Institute, this uses mruby in writing timing and schedule of a imaging from artificial satellite, and Internet Initiative, another company, use mruby for rewriting config and recipe form in accordance with the traffic, and they C is used for basic communications, and CMN company, another company, uses mruby/C for sensor changes or the changes of the data format on a remote basis, and the C language for basic communications. And those are the MRB, GEM, and HAL for microcontroller. So if we had more, you may be able to use Ruby for an embedded program development. So we do like to ask for your support. And mruby and ruby/C porting supports. We would like to begin to think about them and embark upon them. And also some samples like using Ruby, lightweight Ruby on a small scale is what we would like to do. So mruby and ruby/C new API reference is a very good thing for you to know as a guideline for you to use mruby and ruby/C. So I'd like to turn over to Mr. Higashi of IT Open Innovation Center. Thank you very much. I'm Higashi with Inoha. There were challenges I wanted to overcome. Fortunately, mruby and mruby/C have gained popularity, and there are increasing examples of their use. But microcontroller and sensors, there were many ways to use mruby and ruby/C. There are 3 microcontroller board and 3 sensor switches. And 3 times 3 equals 9 different ways of implementation if things go naturally. But this seems a bit of a waste. There were some functions I wanted to standardize, for instance, those 6, GPIO, a general purpose I/O, and analog digital converter, pulse width modulation, and 3 down at the bottom are standards for serial communications. UART for communication module, and sequencer, which is industrial computers. And I2C and SPI are for sensors and display equipment connection standards. So when those devices are considered, the possibility of using different ways of implementations is not quite advisable. For this one is a GPIO and light up an LED lamp. A very simple example. Board A, 2 lines, create an instance from a class and display, and board B, a different class name, and board C, no class at all, only functions are used. So depending upon the board, different implementation occur naturally, and I wanted to more or less standardize such methods.
So it was a situation about 1 year ago. Therefore, mruby and mrubyc and the common I/O class and was started, and I started to pay attention to that commonality. In this project, and I decided to go through 3 steps. That was the initial plan. First one is survey, then proposition and a proposal to be created, and then consensus to be pursued. When doing the survey, the existing Ruby gem is not the only one. In addition, MicroPython, MicronBoard, and the Arduino, and also C+ library Qt were actually involved in our survey. We tried to work out how they were run and used. In the proposition, there was a meeting in which people reviewed them before the consensus MLB and MLB, OSA, and those pioneers were actually invited. So we actually took a Japanese and business-oriented practice. So that requires the in advance discussion and also the information sharing among the parties concerned. In order to create something which is working, and we just decided to focus our effort on the core one. In the essay, and what that should be actually the issue. That was the first task. With regard to error handling, after implementation, you would actually face in various situations. When the version development starts, we can actually add at a later stage. If you look at the code and also maybe one line or so, only part of that, you can actually imagine, you can understand what is being done. So we wanted to make sure that we can do that. That wasn't a goal. The slowing down should be minimized. We tried to make maximum effort for that. So that implementation is working. It's not limited to only Ruby. And if we find anything which is working, run properly, we would like to emulate that successful one. Successful implementation, which is successfully run, we try to emulate. In the beginning, it was a first priority. And the Pico Ruby, OSA, and the developer came to know us, and he said that it's not all that we have to pursue. And he persuaded that we should do more than that. Therefore, this one was becoming of lower priority. And after that, the actual implementation, it's not only limited to Ruby, and keyword could be used, and the keyword parameter was used. And whenever it's possible, we try to use the keyword parameter or argument, and if the same function, the same activity, and then the same method, and the stateless, and was what we wanted to achieve. Let me elaborate on the first point. The code should be easy to read. If we use a keyword parameters argument, the speed might be compromised. It often tends to be slower. However, in constructor, it tends to have more parameters, but actually easy to read and is important. Therefore, we are going to use it. This is a gem serial report which I would like to show you as an example. Object to create 19600 and 8 and 1. So if you are familiar with those things, you can understand what it's about. But if you haven't got that experience, you wonder what they mean, and can we change the sequence of those numerical figures and numbers? So what are they? What are those numbers mean? So with that proper announcement or the definition, the object and the creation should be started. Often in this sort of program, constructor is run only once, and then object is using. The use of object is quite significant. I don't think it will damage, and it has a negative impact to the speed. So based on that assumption, we proceeded. On the other hand, however, some of the methods are expected to be called. In that case, the number of parameters can be minimized, and then you think about the method names as well. Then you can actually design so that this will be actually responding to the call, because it is assuming that a call will be made. This is an SPI XPAR method, XPAR method. If you are actually familiar with that, then you can guess that it is perhaps a transfer, but an acronym is not always necessary. Transfer can be actually written in this way. So we decided to. So when it comes to argument or the parameters, and a transfer is expected. So it is actually the fact. So whatever comes in here should be actually transferred. If you look at this line, you can understand. Therefore, we adopted this design instead of using acronym. So this is the names of method in each class, and common names are used. And if it is actually reading and read, and also writing, write, and also set mode, we adopted those names from projects. And the setting is in a set mode. It is based on the MicroPython's GPIO. Set mode was actually in GPIO, but when you look at another SPI, the names of the unit were different. Therefore, that was a bit of a shortcoming in my feeling. Stateless. In the inside, there is no status to be retained. The sequence of calls is eliminated. I should not say eliminated totally, maybe, but it is almost eliminated. This is one example, MicroPython. The last parameter is a stop parameter. So stop is true or false. And it is the default is not true in that case, unless library remembers that you have to actually change the next action or motion. So inside the library, in this case, you can see the state is kept and remaining. So the library user and the library designer should remember that that is a bit cumbersome, isn't it? Therefore, we tried to eliminate such a situation. Then the design became more concrete and at long last. And we came to this one, which was published. And now it is public domain. Thank you very much for your support. This is a GitHub mruby repository. You can find this because it is published already. If you are interested, please access that site. mruby and mrubyc and C rubies is used. Actually, you are using that and C very much. Therefore, you say that it has nothing to do with my work. But don't worry about it. It doesn't have to be your concern because we have prepared a Ruby version as well. So I am actually admiring my own effort, if you don't mind. On the part of GEM, mruby hyphen such and such are represented in about four are already registered. Please have a look at them. Raspberry and Mark and Armadillo and Micron board are used, and with those Micron board it will be running all right. And in the case of Linux, if the computer is working and running with Linux Micron board, I suppose that it will be okay and there should be no problem. mruby /C supported by you, and we are very grateful. mruby has come to 3.2. mruby/C is also now in 3.2. Get started and also mruby tutorial. They are already made available, and you might have started to get interested in that case, and please do. And next week in Yokohama, there is an exhibition in which you can actually experience an mruby and mrubyc like experiences. Next year in January, Fukuoka Ruby Festa will be convened. So there is no online facility, but please do come to Fukuoka. I would be very happy if many of you come and join that January session. Thank you. Thank you very much for the presentation. Now, we would like to entertain some questions from the audience.
Please raise your hand if you have a question. Anyone? Are there any additional remarks you would like to make? I didn't think of the time for introduction, and you kindly spend 3 minutes on introducing us. Anything we would like to add? Well, even if you want to use it, hardware may be a bottleneck. You have to use it on a microcontroller. But once you overcome that, you will enjoy the high productivity by using mruby, and there is a lot of freedom. So once you overcome the obstacle hardware with our help, then you would like to use mruby. Perhaps you have been using C Ruby, but with IoT embedded program, I think will be more easily available with the use of mruby. Any further remarks from you?
You are forced to ask something, weren't you? So he is now at the microphone. The microphone is now brought to you. Yeah? So that was wonderful. I really enjoyed your program, your presentation. Should I rise? Yeah. So I would like to stand. My name is Sugihara. Nice meeting you. I should not be actually the focus of attention from the audience. mruby, I'm thinking about it, and mruby/C, in those involved in the development and what? So how many people are actually involved? Very small number, actually. So maybe you can actually, maybe maximum 10, not more than 10. Matsumoto-san, how do you like? And so Matsumoto-san has gotten a 10-person power. So you should count 10 people in Matsumoto-san only. So I should say that 20 people. But the number is very, very small. However, so much in a contribution is made. And some of them are very, very shy, and they never come to the front stage. But they are highly professional people with a very expert knowledge. Thank you. So for what people are you presenting that on the part of the development, who would you like to invite to join your effort? Is there any expectation about what person you will be working with you? mruby and mruby/ and C, and we often say that it is easy to use. It's not really true, but I hope that we would like to work together with who can have joy and who can enjoy that fun to use it. And it's not as large as a community. Maybe this group is not deserving the name of a group. C Ruby is actually I envy the C group, and because it is much more advanced. And mruby/ C were separate, but this year we decided to work together. So on a combined basis, and we can put the resources together, which is actually more advantage for many people to join and participate in the functions. Maybe don't think it's too hard. If you find anything, please say that. Is it okay? There is something, and I read your guidelines, and there is still some typo. That sort of remarks and advice is very welcome. Thank you very much. And I used to be involved in that slightly. So 2 people are standing, and 2 people are standing. I am almost in the tears, and that is really moving. So it could never have happened some time ago. So we are working together. So if you are interested in the embedded work, and like an mruby/C, which is rather grounded to earth work, nothing flamboyant, you might be interested. And if you can do it in Ruby, that might be actually some additional fun, I suppose. Thank you very much. Is there any other question?
Thank you. Microcontroller such as PIC24 and Lunasis 201 also were mentioned. Are you going to expand up to other microcontrollers? Is it going to take time if you like to do so? It depends. Well, I think it will take time. Once you have the skills, you have the tips, I don't think it is going to be difficult. But the first bottleneck is rather difficult to overcome. So I'd like to provide you with more examples, then you can learn from more examples, and then you will feel more willing to try. On NPO, we have a porting class. And perhaps you do not know about this event, but if you take part in such a porting class, you will know more. And we are going to also publicize the textbooks. Tutorial and get started, I showed you earlier, may be a very good entry point for you to learn. Thank you. Thank you for the question and answers. If you have any further questions, please exchange business cards with them offline and have a chance to talk. And Ishii-san, you love cats, and Higashi-san, you love dogs, and their attire, clothing seem to be different from each other. But today they had this joint presentation, and they are, of course, good friends with each other. Thank you. The next presentation is going to be delivered by Mr. Nobuyuki Muroi and Mr. Masaki Hirabatake with Kobe City Medical Center. But we'd like to have 10-minute break at this point, and the next presentation begins at 1:40. Thank you. So we are going to have 10-minute intermission.